sidereal year. Bacon is saying that's might have something to do.
He might need to explain that. Sidereal year is just the standard year. Tropical year, I don't know.
Basically, I think there's a difference between the seasons and how long it actually takes the Earth to orbit the sun by about 20 minutes, something like that. And so one of them I think is a tropical year, the other sidereal year. Bacon thinks that's the explanation for this, but I'm still trying to fucking get it. I don't know. Like it's like boggling my mind. I'm not, you know what I mean? I'm trying to like wrap my head around.
Yeah, if you point that pole any other direction, then you're going to change the angle of that window. Period. Shine it. Take a laser and shine it, to a spot on the globe. And if you move it anyway, if you move that pole, then that laser's no longer going to shine any. If you move it any at all in any direction, unless you just simply move it toward it and drop it at the same time. So if you lowered the globe and moved it toward the light, that'd be the only way you could have it stay in to go through that window.
Right. So this is
Bacon. Can you try to
struggling to find about those ones, but
wait. Eggshells, real quick. Let's Bacon. Can you try to fucking explain your sidereal?
Right.
Whatever sidereal versus.
It's 1 day off. By my calculations, it should be a day.
One way you can think about it is to compare with, imagine like a perfectly circular orbit of the Earth around the sun. We have the sidereal day, which is like how long it takes for the Earth to complete a full rotation, right? And if we use the sidereal day to count days, the position of the sun in the sky would shift along the year, right? It would never set at the same time. So every time it's, let's say, 12 o'clock, the sun would be at a different position. So it would shift across the day, right? Across the year. But that's not how we measure the day. We actually measure based on the sun. So we're not using the time it takes for the Earth to make a full rotation around itself, but the time it takes for the sun to reach the same position again. Of course, that's not what explains this. It's just like a similar reasoning that I think might help to understand why the equinoxes shouldn't shift with time. Because if you think about it, you have the time it takes for the Earth to make a complete turn around the sun. That's not actually what a year is. A year that we use in our calendars is a tropical year, which is not the same amount of time of an Earth's orbit. It's actually the amount of time it takes for the seasons to repeat, which, if the tilt is precessing, is also going to add to that time. So the tropical year, assuming it precesses the same direction as the orbit of the Earth, is going to make seasons take a little bit longer to repeat than if we were using just the orbit of the Earth around the sun. So that is how we use our calendars. We take our calendars based on the tropical year, which is how long it takes for the seasons to repeat, which is going to match how long it takes for the equinoxes to repeat. So,
oh my god, dude, the fucking moon! I just fucking came out to the front of my house. The moon is fucking huge, dude. Anybody else?
Oh really? I interrupted me to say that.
I love those crickets in the background.
Anyway, I was thinking about this paper Noah sent me for a couple hours, and I think that's how it should happen. So, the time between one equinox and the other equinox, it's not just a full orbit of the Earth, but when the sun reaches when the seasons make a full cycle precisely. And that is going to match the equinoxes because the seasons are based on the tilt of the Earth. And I think that implies that the equinox shouldn't shift, at least the sun shouldn't shift across many years. It should actually be the same because that's how we count years.
Yeah. Another way to put it is like I posted the thing of the ecliptic and the celestial equator. What the the equinox and the solstice are the points at which those two planes intersect, or the point at which they're furthest apart. If you're, I don't know. Actually, no, I don't know how to explain it. It makes sense in my head, but not. I'm not able to put it into words at the moment. I had a couple of wines last night. Basically, those the celestial equator will precess around, but they're always going to be a high point or a low point.
Bacon said Bacon told me the celestial equator is exactly the same as the regular equator, just up in the air.
Yeah, your celestial equator is like if you projected a line from our equator outwards. That's the celestial equator, and then
I was under the impression that it was like 90 degrees from the North Pole, like period. Like besides the rotation, like just at the point of the vernal equinox, you take the location in reference to the North Pole on the vernal equinox. So that puts it off of the rest of the equator by up to 23.4 degrees. Because the celestial equator is
are all the planets on the ecliptic? Is that roughly okay? So they're all kind of in the same plane, roughly. It's very interesting.
Yeah, that's generally how most systems form. So our whole ecliptic is tilted over quite a bit compared to the galaxy we're in, the Milky Way. But generally speaking, there will be a bias towards once a galaxy forms, it's a giant accretion disk, and that will have a kind of plane to it. And then the same thing will happen within individual systems, which is they will spin quite often on a similar plane to the galaxy, but almost always on the same plane and rotation direction as one another. There are some examples where it's not the case, and I think they've even found a couple of systems where there are retrograde planets, but they think those planets have been captured. The retrograde planets are
like when you spin pizza dough and it gets flat, basically.
Yeah, it's kind of like you're spinning pizza dough and then you're spinning it so fast that some bits like break off and start spinning by themselves. And that's the sort of the idea of an accretion disk turning into different planets.
Yeah, and I mean, if you like see the rotation of the Earth, the orbit of the Earth, the orbit of the Moon around the Earth, they're all in the same direction.
Orbit of even other moons and stuff.
Yeah,
I think there's only one planet that. Go ahead, sorry.
Yeah, are we going to say there's one planet that has retrograde motion?
No, it's rotations. Yeah.
They all retrograde.
Sorry, I don't mean like retrograde in our view. I mean like I thought they'd found some systems where the planet's actually rotating the opposite, rotating retrograde compared to all of the other planets. So not just a backwards movement in the sky for our view, even though all the planets are rotating the same way, they sometimes appear to be going backwards. I mean, actually going backwards.
Yeah. This diagram that you sent writing kind of perfectly explains it at 459. I'm just looking at it and it's like this diagram just kind of like really like explains it with no words being needed.
Can I pick a bone with Brian?
I actually don't get that fast. I'll have to stare it for a while longer.
Dude, it made like after I saw this, it kind of falls into place for me at least. I'll have to think about it a little more, but this on its face kind of makes a lot of sense.
Right. Anyway, I'm gonna go now. See ya.
See you, Bacon.
Good night.
Thank you for your
Brian. Brian.
I hear you, bro.
I got out of bed, went out to my front yard to the pond, all the way to the street in my underwear to see this gigantic moon. And there's no moon in my sky.
What? Where the fuck are you at, dude?
Louisiana.
Well, go back out there in about. Let me see. It's about. It ain't on the horizon, so you should be seeing it. It is. Let me see.
It's about 20 degrees for me. My wife was just saying how big it was. It was orange a minute ago.
Yeah, you guys are both on the East Coast, and Rakia's not quite on the East Coast.
Wait, where on the East Coast are you? You ain't got to tell me exactly, but you know, like north, south, central, like on the East Coast.
I'm in North Carolina.
Okay, so you should see a big ass moon right now, right?
Yeah, it's about, let's say, 20 degrees up.
Yeah, that sounds about right. It's basically south, let's see, southeast.
Yeah. Yep.
And yeah, I'd say it's about 20 degrees up for me too, man. That sounds about right. It's up over the tree line. It's fucking massive, dude. It's orange.
It's below my horizon.
Rocky, I'm sorry, man. If you did all that, then I almost want to talk and keep talking to you for another half hour so you could see this bitch. It's some fucking Mortal Kombat moon, dude.
I might stay up now.
Posted the thing. It's Venus that spins backwards. You're gonna love this. The apparently Venus spins backwards because it flipped over at some stage. That's what some of the theory is.
Yo,
Yep. You know, its orbit is just about as long as its day is. So its year and its day are just about the same length.
Yeah, it flipped. It had the force to flip, but then stop.
Well, no, it's not. It's in freeze space.
Wait, I have a question that's really relevant to that comment. Why doesn't the fucking Earth run out of momentum with its spinning?
It is slowing down.
Well, the moon's
so minute you can't measure it.
Yeah, the moon's slowing it down. There's other things slowing it down, but it actually, like, I think most of that is slop of the tides and things like that. Just continuing to spin doesn't take energy.
Will we ever flip?
Yeah, I haven't heard anything suggested.
What causes the flip of Venus?
I think that's just a theory.
It's a weeble wobble.
Well, it's already spinning super slow, so you know someone could have hit it.
Seems to be no reason. I mean, I understand that they kind of say these cap corrections, but and it is on my head, so I'm sorry on the Dunning-Kruger, but couldn't there just have been an object that came from a different area, and so it was spinning in the other direction before it got captured?
Yes, I think that's been one of the theories for Venus, or for generally planets with retrograde motion, usually orbits rather than rotation. But
wouldn't it stop its rotation and start rotating in the correct motion?
No, I'm pretty sure that seems very improbable.
But it could flip, though.
Extraordinary amount of energy to
something.
Well, if a meteor whacked the fucking side of it or something, I don't know. But
yeah,
I mean, this is all fucking speculation. There's no fucking way you can
think
verify any of this shit.
You think?
Well, yeah, but you'd have to.
You can interrogate their current theory on how it happened,
or you can just trust it. Put it in the bucket of faith again.
You wouldn't have to trust it. It's what you would. So you look at the observation, you see, and you try to come up with what could have caused that, and that's one of the things that could have caused that is early on something huge smacked it so hard that it basically neutralized its rotation.
Or you just put a bunch of BS in a bowl and have a pretty girl pick one out and say it flipped, and then put it on the science network, and then people like you just put it in their faith bucket.
Now, the difference is you can be a thinking man, or you can not think about it at all.
I'm thinking they could come up.
Thinking about it, you come up with the most likely explanation
that it flipped, even though we haven't seen anything else.
Yeah, that something would have smacked it and it flipped.
Yeah, how did it stop?
What Scientific American is saying is it could have been. Let me go back.
What's it on a table?
Still puzzled by its backwards rotation. It won't take much, as you were saying, because the days are very long, so it's not a whole lot of energy to do. But these people have a theory that it flipped 180 degrees at some point. The gravitational pull on the planet's very dense atmosphere could have caused strong atmospheric tides. Such tides, combined with friction between Venus's mantle and core, could have caused the flip in the first place.
Exactly. Like I said, they could say anything.
Well, it's better than saying nothing.
Well, look,
exactly. Not.
I was saying.
So lying to someone is better than being silent. Jesus.
So apparently this one is saying it could have slowed and reversed direction.
That doesn't make any sense for me.
Why wouldn't it do it over and
Why would
over
something
again?
If it had
slow
a
It was
and
on the
side,
same
I don't-
speed.
I
I guess in a trillion years it's going to flip again, right? Is that the theory?
not what it says here.
They've done the calculation.
Well, you know, eggshells, what it almost looks like, because, like I said, its year and its day are almost the same length. And usually when that's the case, it means that it's tidally locked. So when it's tidally locked, it'll be the year and the day are the same length. And that's actually that's the most common. So most of the moons in our solar system are tidally locked. So something that's misshapen, like you said, the atmosphere
tidally locked
gives
to
it
the
this
sun.
misshapen mass. Say what?
You're basically saying it's tidally locked to the sun.
No, I'm saying it could be on its way to being. It could have been almost tidally locked, or on its way to being tidally locked, or
With the sun,
you know,
though, right?
yeah, with the sun.
Now
It's a
we
very
have Coaster
common.
making it up.
It's a common.
That makes sense because it's
orbit.
close to the sun. It's a second off
Yeah, well,
from the sun. It's supposed to be the close, one of the closest, right? It's supposed to be so close we don't really even observe it outside of the fucking certain degree from the sun.
Well, it's the closest one with that much atmosphere, which says that it's like a kind of. It's got like a fluid, fluid shape. So I don't know if that's going to make it. Because that's why planets become or moons become tidally locked, is because while it's forming, while it's still molten and fluid, the gravity is pulling at it in different directions. So I mean that they honestly could have something to do with it.
Was this a gas giant or a physical rock that flipped? The sphere?
It's got a surface. I was listening actually to a cool ASMR sounding talk about it yesterday, where like back in the I think it was 1800s, there was all these people who thought there was life on Venus, and they were like, oh, you can see lines which are obviously like roads or something, some sort of like structure, and that they were talking about like apparently there was a prize offered, $100,000 prize offered for catching the first extraterrestrial transmissions, because they were like, well, what are the Venusians up to? They must be trying to contact us. We need to listen to what they're saying. But yeah, now I think that they're fairly sure that it would be.
How'd that work out?
Inhospitable.
I still think Venus somehow has something to do with our earthquakes and shit. And Mars. I think the rocky planets and shit, when they're passing by, would definitely have some sort of effect on the Earth. Or maybe the weather. Maybe not earthquakes, but something to that effect.
They would pull our atmosphere off if it did
the moon
that.
literally fucking drags the fucking ocean around, right? And the moon is small compared to planets.
No, it doesn't.
According to your fucking globe fucks, all right? I'm not fucking saying from a flat Earth perspective.
Well, it's kind of strange that the tides are in
from a flat Earth perspective. From a flat Earth
correlation in sequence. Yeah, no problem.
What were you
but
saying? Left
physically moving the water.
I was just saying there is a correlation to the moon's orbit and the tides.
My watch correlates with the sun being over my head at noon. Doesn't mean my watch is making the sun go overhead.
Yeah, but it does mean that your watch is
not really.
Yeah, it actually is. Your
not
watch
really.
It's made to be matching what the sun's doing. That's what.
In sync, not causing anything.
I mean, what do you attribute the tides to, Ricky?
I think it's an electromagnetic effect.
We're not saying.
That's why they call them currents.
It's got to be electromagnetic, man. It's whatever's causing the phases of the moon.
Yeah.
I think are attributing to the tides, because the tides are anything but consistent. They're anything but consistent. There are areas. There are nodes where there's no fucking tides at all in certain parts of ocean.
Moon. There's moon overhead these places, but there's no tide. But the moon causes the tide.
The only thing that matches with the moon is the times. Like they back up the way the moon lags behind about
in sync.
An hour a day. The tides do the same thing, but there's two of them a day, 2 highs and 2 lows, and
I don't see a problem with 2 of them a day.
Yeah.
Like if the moon was causing it, 2 a day does make sense. But what doesn't make sense is that it's the moon doing it physically. It's just
Okay.
a sync in sync. It's a cycle, another cycle. Shocker.
Yeah.
All right. So if everything is determined by this electromagnetic, whatever, the moon, the tides, whatever, would it not be possible on your flat Earth model for the period of Venus moving around the fucking sky to correlate in some way, or Mars, or Jupiter, or anything in some way to the weather and earthquakes and shit? Would that not be? You're saying everything's electromagnetic and on these circuits and in these determined frequencies.
Yeah, frequency. Yeah.
Right. So, like, if it's indeterminate that way, would those natural things that occur not line up with fucking
everything?
stars?
Everything would be a part of everything, and every cycle would affect every other cycle. It's called a dynamic system. The more thermal energy you put into a system, the more turbulent it gets, i.e., weather.
Another thing, if you want to attribute the tides to the moon physically, you would think that the strongest tides would be during a new moon when you had the sun and the moon lined up together, and it's exactly opposite of that. When the moon is away from the freaking sun and we get a full moon is when we get our biggest tides, which is exactly opposite of intuition on a globe model.
Well, when you have the certain cycles of this thermal energy, let's call it the sun, right? And it goes around in a perfect circle in and out of an equator, then you would have certain weather patterns that develop certain times of year. And when you have these thermal input and energy input into a system that's creating winds that called trade winds, or winds that go in a certain direction certain times of year, then storms would develop in certain areas every year, some more than others, but in the same areas, develop into bigger storms and turn in a certain direction because of the winds and the weather. That's how weather works.
What about earthquakes, bro? What about earthquakes? What are earthquakes also?
Yeah, I've only been a part of one earthquake. I was in Switzerland, Zermatt. I think it was in Zermatt. I was really young skiing, but I slept through it.
To be for an earthquake.
Yeah, I slept through it. I was in this goose down bedding that was so comfortable. I slept all through it. At breakfast, they were telling us how bad the earthquake was and how many snowdrifts, whatever when the snow comes down the mountain.
Avalanche.
And I didn't have one. I was like, yeah, I slept right through it.
Yeah, because that is steep stuff there. Where I went to Zermatt and they were going up in choppers. It was very cool to watch. Dropping what I was told was sticks of gelignite, lit sticks of gelignite.
Yeah, they shoot them. They shoot them up there too with cannons. Like they'll shoot them with cannons and like an artillery shell and explode it. But I flew into some part of Germany. We rode a train. We got off and there was like machine guns and stuff. It was just weird. But we saw the Matterhorn. Where is that at? Is that in Zermatt?
Yes.
I was like 10 or 12, so 40 years ago. But the Matterhorn, we saw that. We rode a train up the side of a mountain. It's like a trolley or whatever. Crazy. Beautiful country, though.
Not cheap, though.
Good thing. I wasn't paying for it back then.
Where is it?
Zermatt, Switzerland?
Oh, Switzerland fucking runs the world, bro. They avoided World War II.
I think of earthquakes as like lightning bolts moving through the ground.
Trembling, yeah.
Yeah, like through the magnetic ley lines, which they call the fault lines, but you had
as above, so below.
Yeah, I wish I could find it, but there was this one fucking person who was always like on about Venus and it being able to like predict the fucking earthquakes depending on like the cycles of Venus or whatever. And like I found it so interesting, but I just can't find it again. So I've been trying to fucking re-find this thing the whole time.
I wouldn't doubt the sync of it, right? Like the moon,
Like
phases.
this guy would basically go to old articles of like when earthquakes would happen, and then like he would use this like star chart and shit, and he'd be like trying to show how like it lines up and stuff. And I was like, I don't know. I need to find the channel and scrutinize it harder, but I just can't fucking seem to find it.
Yeah, in this electrical world, right? Like everything's in sync. You would have these releases of energy, like lightning, and if it's underground, it's a big release of energy. Think about all the processes there, even in your globe model, what's going on underground. Of course, there would be trembles every now and then. Pressure release. I mean, yeah, we're going to shake and tremble a little bit sometimes.
I've never been near a fucking volcano, man. There's all kinds of fucking ridiculous shit. You can hear
so much
everything
pressure
underground. It's all moving. You can hear all this shit moving and stuff. Volcanoes
Think about
are
the pressure coming out of the side of that mountain to make it explode and go that far and push that lava, all that mass out of a hole. It's a lot of pressure. Heat contain pressure, right? Container. Pressure builds up, that's the container. Fill a balloon up too much, boom, got you a volcano. Pressure release.
If we've only drilled a hole, 9 miles down, where's all the lava at?
Well, I don't think there's lava everywhere. You have veins, gold veins, lava veins, silver veins, coal veins. Different pressure and temperature creates different minerals.
Varicose veins?
Yeah, varicose veins. Veins in our, same thing. As above, so below. The veins of the earth, right? You're getting it. Kind of why I think we're all connected in some type of way. How much longer I gotta wait, Brian, to see this gigantic moon? Put my flip flops on this time. My feet are tender.
Let me see. You're about let's see. If you are about 500 miles away from me,
Mm-hmm.
let's see. Let's just say if the moon moves about 15 degrees an hour, then it's a couple hours over the what time? Let me see. What time is your sunrise?
I don't know. I'd have to look. Right now it's at like 6:15, 6:20 in the morning, sunrise.
Hold on a second.
Sun's getting closer to us, getting hot. Days are getting longer. Bet it's getting colder in Australia.
Yep. I mean, it was a pretty wet summer anyway.
Yeah, sun's getting lower in your sky. Rising more in the east, setting more in the west type thing. Northwest, northeast.
Yeah, well, it was a few weeks back was rising south of east.
I know it's changing fast, right? I think when it goes over the equator, it seems to really move. And then I think it slows down a little bit because right when it right when the days get really long. It only takes a couple of weeks, and then they stay long for a long time. It was cold here today. Like, we had a cool front come in last night. A little bit of thunderhead and shower, and then it was cool all day during the day. Chilly. Weird. Because it was balls hot Saturday and Sunday. That weather can move quick. Brian's outside again.
I think it should be 30 minutes till he sees the moon. I could be wrong about that.
Another 30 minutes?
That's what I he said 500 miles, right? And then it's 1 degree every 69 miles, right? So,
but it was 20 degrees in the sky already. In his sky.
Oh, he already saw it. I thought he didn't see it.
He's seeing it.
Never mind then.
No, I haven't seen it. I'm 500 miles to the west of him. But it was 20.
I just took a pic. I took a picture of it, but the camera didn't do it no justice. But it's I just used my phone. But yeah, your time is 1 hour behind mine.
Yes, 10:30.
So yeah, okay. So it's 11:30 here. So I guess we got to take that into consideration too. But
bend
it shouldn't
over.
be too long, man.
Bend over and look through your legs at the moon. See what it does.
Yeah, it's already up. It's already up a ways. It's starting to get smaller. Just
no, but they say it gets tiny when you do that. I just can't do it.
That's so fucking stupid, dude.
Do it.
Dude, it's fucking huge on the horizon, man. Like even if there's nothing else, you know, even if you're looking aquatic, there's no water, nothing else to reference. And you can see it get smaller as it goes up above the trees, and then when it hits about 35, 40 degrees, the whole rest of the night, it stays about the same size.
I think it's just being magnified. I think at the horizon, it looks closer and bigger.
I just changed modes on my camera, and it changed size actually, and I put it. It did like a night vision and an auto moonshot. Every different mode I had, and the moon was a different size. So whatever you do to try and measure it with optically, you might get the same shit, dude. But I'm telling you what my fucking eyes see is sometimes, not always, but a huge fucking moon sometimes. I mean, fucking I've pulled over. I've seen coming back from over where they launch all the boats and shit. Like multiple cars pulled over. This is a long time ago. It looked like it was scary, dude. Literally scary how big the moon was. It like what's wrong? There's a problem because the fucking moon's so big. But it's always bigger to me optically on the horizon. But you know, you can call it optical illusion all you want. I'm telling you what I see, and sometimes it's fucking real big. But to me, it seems always to a certain extent bigger on the horizon. Now they can't admit that, so of course it's an optical illusion.
Well,
it's not part of the heliocentric model.
Well, you could hold like your thumb up to the moon and sort of measure it with your thumb when it's on the horizon, and then do the same thing when it's overhead, and you'll see that it's actually.
I'm sure there's explanations. Yeah, I'm sure you could do that with fucking a butterfly or something. You know, just hold your pinky nail up, dude, and the butterfly is gonna be about the size of your pinky nail. They're all the same size. You know, about the size of your pinky nail. Anyway,
chat with IB Hunter in my server, but he's would be an interesting person for you to talk to, Rakir, because he says he's gone out and mapped the ocean and used gyro compasses and stuff.
How does a flat earther explain a gyro compass?
Ether, I think, is the most common explanation.
How does a globe earther explain a gyro compass?
That's
Rotation.
that's actually easy, but I'm not. That's not even answering my question. So like, why don't you explain how you like explain a gyro compass? If you can't, you can just say
No,
I don't
I'm
know
asking
how.
because
You don't need to ask the question.
gyros are supposed to be fixed in space, right? So when we travel, you know, why don't they turn? Why don't they show us, in, you know, especially in airplanes or whatever, boats, anything? Why don't they show us turning? Why don't they show us bending over? You know, starting to go downward. You know, any physical, digital laser, ring laser, fucking. What's
That's
the other
true.
one?
It should
The
be. It should
fiber
slant.
optic. Yeah,
It should
none of them
slant
do
1
that.
degree every.
Why
It
don't
should
they
slant
show
1
that?
degree. 1 degree every 69 miles. It should slant 1 degree every 69 miles. That would be a good experiment. Start up a gyro. Start up a
It's been
gyro,
done.
drive 70 miles, and see if it moved 1 degree. 1 degree is very small though, but
No,
still,
they
that's
don't. They claim that they don't even claim it works on the y-axis. It's just, you know, they can't. They've never gave me a good explanation. They just say it doesn't work on the y-axis, but then they tell me its sole purpose is
don't
rigidity in space.
airplanes have these things? Aren't airplanes
Yeah,
equipped with these things? Airplanes
So,
go
yeah,
like
shouldn't the horizon they have to adjust it? Why does it only process in circles? Okay, why doesn't it process? I mean, why doesn't it show going over a curve? It should.
so say like an airplane's going 350 miles an hour, right? You're gonna what?
No, why is there one special axis on Earth, only on the ground or whatever, or in the air?
If you're on a plane going 350 miles an hour with a fucking gyro, after an hour the gyro should be fucking tilting by about 5 degrees, I believe. Yeah.
I agree.
It should be. It should be tilting 5 degree. That would make perfect sense if it's retaining its rigidity in space.
Yeah, and if an airplane's going like a MiG or something going 1,000 miles an hour, then you know it should really fucking
I go that fast?
Oh wait, let's say Blackbird, man, 2,140 miles an hour. Let's just say 2,000 miles an hour. So in 15 minutes, that's 500 miles, man. In So in 7.5 minutes, that's about 250. 3 minutes. I've done this shit before, but I'm just trying to get close. So it's about it's about a third of a mile a second.
Holy shit, dude! The MiG goes
wait.
Dude, one of these MiG models goes 2,000 miles an hour, dude. 2,000 miles an hour. You know how fucking fast that is?
I don't know if a MiG does that fast.
No, it says, look, the MiG-25 Foxbat, capable of Mach 3.2 or 2,190 miles per hour. Let's divide that by 69.
I was just figuring
That's
this.
30, dude, after driving in that MiG, if you're in a MiG-25 Foxcat, if you go for an hour, your gyro should be 30 fucking degrees off. That's like what, 1/12? Or like, what is, that's ridiculous, dude. 30 degrees off after an hour? That's 1/12, dude. That's 1/6 of a fucking protractor. That's ridiculous.
That's more than the sun, eh? Twice the change of the sun.
Yeah, 30 degrees in 1 hour if you're on that MiG. If it retains its rigidity in space as it should as a gyro, right? It would move 30 degrees in 1 hour if you're sitting in this MiG driving it. I mean, that's just a MiG, dude. I can look up the fucking F series. They're probably even faster.
I know that the Blackbird, the what is it, the SR-71 or some shit, SR-70, it does like 2140, but it's a little over a third of a mile a second, man. And so you're booking, man. You're fucking booking. That's the guy who was up about, I think he said about 60, 70,000 feet, and he could see the fucking Rocky Mountains all the way up into Canada. He said from Arizona, he could see the the western seaboard, looking down from like San Diego up to fucking. I mean, it's crazy the way he was describing it. But besides that, if you just look at high altitude footage before even the super long distance claims, if you go to Google Earth, it's they say it's a ball, but to me it's flat until they start getting, you start zooming out. Maybe I'm wrong, but and it shows you how far you're supposed to see, basically. No refraction or nothing, but it's not even close to reality. Any pictures I've seen in an airplane, even pictures that like aren't trying to prove flat Earth, it's if you go up to the elevations, it's just not what we see in reality. What we're supposed to see mathematically, even added some refraction, is grossly off from what we really see up there. And out there, I guess it's supposed to be, minimal refraction. The higher you go off the ground, and that's just not what we get, man. If you don't believe me, and I'm not trying to make any claim like, maybe Google Earth is maybe the elevations are wrong. I don't know. There's 100 things it could be, but just from the claim of it, the claim that it's a ball, a simulation, and with a certain amount of curve and whatnot, it certainly doesn't match. That's the only claim that I will make. It doesn't match with reality. I understand that looking at the sun and shit, especially zoomed in, it's worse in some places, but it looks like, it's going down, like straight down. Some places ain't as bad, and in the deserts and shit is where you're gonna get the least effect of that, where it looks like it's kind of going away. But it definitely stalls on the fucking horizon. Stars, everything, they stall. They slow down aggressively too. So when they first start slowing down, it's a little bit slower than at the end toward the the horizon itself. They're going to their absolute lowest, and it's fairly consistent, man. I've seen it mapped out with on screen, and they say like the refraction's like 15 degrees. It starts at like 20, 25 even degrees where they start to slow down. That 15 degrees an hour shit was uneven. Once you get down to about 20 degrees, that shit's out the door. That last hour and a half, it's no longer 15 degrees an hour. It's slowing down, and I don't know really what that means, but to me, claiming 15 degrees an hour and shit like that, I mean, that to me, that's what I would expect over a plane. If it was just, I will admit also, like the math, it going on. I'm not saying I know what the sun is, like it's a tangible object, not making that claim, but entertaining that if we know what it is and it's something that's definitely in the spot where we see it, then the math needs some help, and it would have to be some sort of refraction, or something like that. And that's why, but that would follow. That would follow, The math even says on a flat plane that the further you go, it would have to start slowing down if it's just going away from us. And it's going further and further away. But as far as the claim, as far as it changing angular size, if it never gets within if the closest it ever gets is 4,000 miles or 3958, whatever, just a guess of mine, or just the math. Oh yeah, sidetrack. Wondered where that 3958 came from. 3959. He's saying there's probably a correlation to something. There's an explanation. That's 1 degree. 69 miles, 1 degree of flat plane trigonometry. I believe that's where I got that from. I believe that way quicker than I believe 500 miles. Dudes with no synced watches looking down a well measuring shadows 500 miles apart when on the way they could have measured the star, the Polaris, 5 times. Watch it. If they could get an accurate 69 miles, they could see it drop pretty damn close, if not right on 1 degree every 69 miles. And like I said, flat plane that drops down. I mean, that triangulates to 3958.7, the exact Earth radius. But what I was talking about is the sun. So if it never gets within 4,000 miles, and then it sets at about 6,000 miles, it's 12,000 mile viewing radius. So 6,000 coming in, 6,000, and that's only if it's straight overhead, because it gets about 4,000 miles close to it. So it's not getting that damn close to us to be changing size like that. It might, if you want to use percentages, then that's not being honest, because if we look at things overhead, they're not changing angular size like things down here lower or just close to overhead.
Well, some of this stuff is approximation.
If you look at an airplane.
Because if you take 24,901 as the circumference and divide that by 360, you get 69.1 degrees and some change. So, most of this is approximation anyway. We need to see how much, reality actually goes with these idealized numbers as it is. And over a flat surface, you'd still have, a certain degree of dip per unit distance. It would just flatten out as you get further and further away from the object, which is what we see with Polaris lingering on the horizon as you get toward the equator anyway. So a lot of this stuff isn't even necessary for a ball per se. It could work on a flat plane.
Yeah, things like airplanes, if you watch them, the ones that are way high up, even when they're right overhead, use full zoom, they're not barely covering the screen. Same thing as when they get as far away before they just get opaque and you can't really make them out. I mean, they don't really change angular size, nothing to speak of. They're small as shit when they're directly overhead and 7 miles, and then when they're twice that far, when they're probably 14 miles, maybe even further than that. But they're same size basically. I don't know if you could measure a difference. It's very little, if any. So as far as the angular size argument, I think that's a wash. Not to mention, we don't know what the sun even is, but to me, sun and the moon are bigger on the horizon. And
well, after 90 degrees,
they have to.
Well, when you take 24,901 and divide by 360, you get 69.16 degrees or whatever. And so after 90 or 100 degrees, you're off by 60 degrees because of that change that's left over, since it's like 69.16 degrees per degree. 69.1 degrees, or something like that, 69.1 miles per degree. And there's some change left over. And so, you're going to get an error bar even with that after 90 to 100 degrees of 15, 16 degrees based off of this idealized math. So, some of this stuff isn't quite what they're telling us. There's a hole here, a hole there, even in their narrative with their approximations and stuff like that.
That's a good point, Lemon. That's a very good point. Another point is these stars they're not all 69 miles per degree anyway. Look at that only works one direction. That works with only one we know for sure is close to that even is Polaris. Look up north. Look at the longitudes. Okay, it's supposed to be. Why did they even change? So you had a nautical mile. It's a fucking mile. 60 per degree. It was for hours and minutes. And it worked good. Why would they even change that and give us a different kind of mile, a statute mile that's supposed to be the same but different? It's just stupid. Why would they even need that? But the thing is up north, the longitudes get tighter and tighter. They all the way to the pole where 1 degree is only 10 miles or something. But even where in populated areas, like in Norway,
it seems like they're trying to acknowledge some of the assumptions they're making, because making a straight line at sea is impossible because the water is tossing you here and there with the waves. On land, you could, invoke a statute mile because you could walk it. You could take a straight line or a chain, along the surface, but on the water, that's impossible. So they have to look at the sky clock and have a nautical mile that kind of assumes that the sun is circling overhead like a clock, and you have degrees, within that, circle or something like that. So it's a mile made off of different assumptions.
I bet it's exactly opposite, Lemon. I bet they were saying, well, on land you're more prone to of elevation changes and shit to through the 60-mile journey that you're probably going a lot further. So they probably add 60. Where on the water you're more close to level. But yeah, technically I'd agree with you. But that probably wasn't their reasoning. Their reasoning probably was the elevation changes that you're probably going further. You might be right on that, but I was just
Well, a nautical
kind
mile and a
of
statute mile are related by 1.15. Like 1 knot is 1.15, statute mile. So you add about a sixth to get a regular mile. So like I think it's every 6 nautical miles you get 7 statute miles, basically, roughly.
Well, the way I understand it is that one one arc minute is 1 nautical mile, and
Right.
if you look at what an arc minute is, it's an angular measurement. So I believe that they had to use the 60 for the sexy was it called sexagesimal? Is that what it's called? I don't know if I'm saying that. I don't know if I'm saying that.
Sexagesimal.
Yeah, that's the 60 by 60 system, right?
Yeah.
And because you have time is like if you're looking at coordinates, you'll have time in there, right? Like it would be the degree and then the time. And you wouldn't really go into seconds, but you would always go into whatever degree and then whatever minutes it is.
Yeah, they're saying they're pretty much saying a celestial sphere. They're arcing the sky. They're just basically comparing it to a circle to give us the fucking the measurements, the arc minute and the arc seconds, all that. But look, it's only really accurate up close. When you start getting far and shit, it breaks down, and there's no way to even prove it, man. How could you prove distances, man, with one continuous line on Earth? I don't believe,
Well, there are 60 minutes in a
distances that are
degree.
questioned.
Well, there are 60 minutes in a degree. So when you take 360 degrees times 60 minutes, you get 21,600 or something like that. And when you take the supposed circumference of the Earth, 24901, and divide, 21,600, minutes, you get 1.15. So that gives you the conversion between nautical miles or arc minutes or whatever and regular statute miles, supposedly. It just looks like they've gone out to sea and assumed that the sun circles overhead in an arc, even though they can't, necessarily verify that with a straight line at sea per se.
When they talk about their degrees of accuracy, like good, at least talking about stars, good down to such and such arc second. Yeah, I would hope so. If the motherfucker's this many trillion miles away, I would hope you would have it down to the arc fucking zigga nanosecond, If
Well, I
if
mean,
you're
there's
talking
going to
about
be
stars infinite distance away, that ain't impressive to me.
Well, these numbers are going to be approximated either way. I guess it's just the underlying assumptions that they use to evaluate the numbers that they get. They're assuming that we're circling over a ball sphere, but we could just be circling over a flat plane and following the circle of the sun as it circles over said flat plane without it necessarily being a sphere.
But I've seen a video of a guy. He pretty much represented the ball Earth with a table and a phone, and he put a bunch of lights up there to represent the stars, and then he spun it. And if you have that thing dead center, I mean exactly dead center, you can represent what we see on Earth. But if you move it just a little bit, and I mean just a smidge, then it shows what's overhead. And especially if you tried to go to the outside of the table and angle it towards the middle, no, you don't get circles like that, man. But then he kept the phone stationary and moved the lights, and then you could put the phone anywhere on the table and angle it toward the center, and you get what we see in real life. But like I said, it matched perfectly what we see with the lights turning from anywhere. But like I said, when you tried to change the camera from anywhere dead center, it did not work.
Hey, Brian, excuse me just a second. Gio, are you handy?
What do you need Geo for?
Yeah, it's going to. Writing was wanting to possibly do a host role, a temporary host, and bring IB Hunter in to talk about mapping the oceans. And I was going to ask Jill if that'd be okay with him. He's probably around and can hear me, just didn't where he can unmute. Go ahead, Brian.
No, I was just bitching about the globe.
Okay.
Well, at best, all we have with these numbers and the way that they're interpreted is some sort of circle. So it could be a flat circle or it could be a spherical circle. So at that point, the possibilities open up to it being flat or round from there. But more than likely, it's flat as far as I can tell.
But even with the stars being infinite distance away, okay, that's an argument. That's an argument to explain that camera thing. But same thing with the moon and the stars. You change the angle. If we're the ones spinning, so it wouldn't apply to that. The moon's not an infinite distance away. So I don't know. There's probably an explanation for that, but it doesn't work. For practical purposes, it doesn't work with trying to replicate it locally with the table. It's exactly what I would think too. I think Chris Berry did a version of that experiment, like with put his phone on the rim. But I mean, think about it. The camera is going to show what's right overhead, and if that was the case, then that would make sense that however many miles per degree would be consistent. I don't know. I was just thinking about the miles per degree, like even in Norway, even populated areas up north, it gets down to about as low as I think 30 or 35 miles per degree, and that's I think to have made an accurate globe map, they would have had all great circles. A convergence at the prime meridian, let's say, and the opposite of the prime meridian, like converging. So basically take the longitude lines and also run them sideways. So you'd have 4 points of convergence: the North Pole, the South Pole, let's say the equator, the equatorial prime meridian right there, and the anti-meridian on the other side. And that would represent a ball accurately and directions we look. Because they say the only time we're looking straight in real life is looking at a great circle. So if we're looking east along the latitude line, you can't see that direction. I mean, you flat out can't see because that line's curving around. And so why would they even make it like that? I think they made it like that to confuse us. Because of the equinox, because of the way the sun does on the equinox. Because I don't know. I don't want to say that whole story again, but they had to make the map though. With circling out from a central point. I mean, in reality, they had to have, man. I don't see how they could have got around it, no matter what the Earth is, because you got a star that. I mean, first off, you got heavenly bodies that are very, very consistent, okay, in their cycles, and the stars are in the same cycle all year round, just in different places in that their voyage. They're consistent as far as distance from each other. They take the same path all year round, just at different points, different speeds, you could say. But and the sun and the moon, and the planets, whatever, they have consistent cycles. So it only makes sense to start from a point that's reliable and not moving, and then measure away from that and the degree it drops. So you're going to make circles away from Polaris. I mean, in my eyes, that's the only practical way to even go about starting it. And when people bitch about the A map and the problems with it, this and that, I mean, I even had somebody challenge me that how on a flat Earth do we have converging longitude lines and diverging longitude lines? I'm like, what are you talking about? I'm like, the fucking longitude lines converge at the fucking North Pole on a flat map, on the A map, Gleason map, and they diverge down to the equator. And so really, if you're talking 20, 30 degrees below the equator, it's not going to be that big of a damn difference. It's going to be pretty much right on, within reason, to the equator. You have the converging longitudes, and further north you go, and spreading out further south you go. So there's not much contention, if any, in the northern hemisphere. And then just think about 10 or 20 degrees below the equator. You're talking about the biggest part on their globe model, the equator, and 10, 20 degrees beneath it. So to try and narrow that down is just impractical, man. It'd be impossible to prove, in my opinion, with the oceans down there. But it'd be easy to map it however they wanted, man. They have giant oceans with wiggle room, man. With wiggle room. But then it's even better, because when you start getting beneath 30, 40 south, there's no fucking people there. Hardly at all. And it's also crazy, man, like when you're trying to look at distances on flight plans, shit like that, like Hawaii, I'm trying to get distances and flight times, and I'm looking at the southernmost island, and it's like the big island, and there's like no major cities on the biggest island in Hawaii. There's no major cities. I'm like, what the fuck, man? And it's a good bit lower than like where Honolulu and shit is, so I could get some times that might help their model or might hinder it. But I'm looking for spots that I feel like there would be differences, some anomalies, and they hardly exist, man. Like you find a perfect spot to do some comparisons, and there ain't shit for fucking cities there. So there'd always be some kind of bullshit connecting flight anywhere, not just Hawaii. It's like the way the shit. And then I was looking at the declination of there's a calculator, a way to do the math and all that shit. And if you look at every continent, if you do the continent separate, it'll show you the United States. You got to look real hard to get other continents. But look at the magnetic declination is a sphere. It's pointing outward in every direction. It's basically has arrows pointing straight down middle of the United States or North America, and curving up and out, or down and out the further you get to the edge. It's basically it's trying to two-dimensionally map a fucking circle, an anti-circle. It's like, what the fuck? Anybody interested in having any clue about what I'm talking about, look up magnetic declination and look at the first picture you see, United States, and you'll be like, what? So that's the direction we're really looking and everything. But so I supposedly have magnetic declination here, but my compass, I can see Polaris and the coastline, the compass. My compass is pointing at Polaris. Why are they telling me that it's declined from Polaris? Because I don't know. But to me, if you're going to give me magnetic declination, I can eliminate that and get pretty close to a flat Earth map, man. That's a couple adjustments I'd have to make, but just eliminate that in most areas. I know it'd be existing in some areas. I'm not pretending like I know everything about it, but just from the face of it, it really does. I mean, you just got to see it. Just Google magnetic declination map, like the United States, and look at the way the arrows are diverging down and out from the center in every direction. And it's like, fuck, dude, they fucking made it into a ball. And they don't tell you this shit when you go to sun applications. You go to SunCalc, you check the fucking, the directions for the equinox. They don't tell you that. I mean, they may say it somewhere in the fine print, but they tell you, you're looking 0 degrees. So if your freaking magnetic declination is 11 degrees. Like Mitchell from Australia is the one who put this to my attention. Is he took it said that his sun was going to rise due east, where he was at as the equinox. This is this year, just a couple months ago, and sun calc, was dead on. It rose due east according to sun calc, and according to the maps and all that. But then he put his compass on it, and it was off by 11.5 degrees. So the sun wasn't coming in from the southeast. It was coming, or east southeast. It was coming in fucking slightly northeast. Exactly what we see, and they say, "Well, how's the sun coming from the south?" No, it literally wasn't. Now, if you're gonna wholly, take the magnetic declination wholly fucking serious, then yeah, it came in slightly southeast, mostly east, but slightly south, east south, or east southeast. But like I say, 11.5 degrees according to the compass. It was coming in what we would expect, closer to what we would expect with a AE map, and we just turned the declination a little bit more than that. So instead of declining that direction, however far it's off, then that's the declination, because we know the Earth's flat. I'm just saying this, okay? So we know for a fact the Earth's flat, and we know where the sun's at. It's coming in this circle. So 6,000 miles away, it should be a little bit more north. So the declination would be a little bit to the north, 11.5 degrees. Now what do we have? We have it matching the fucking AE map perfect. So everywhere that it's off, we like I said, eliminate magnetic declination, and you're going to get closer to accurate on the AE map. But then whatever it's off past that, then we just decline it what we need, because that's what they did pretty much on first glance. I'm sure there's people probably punching the screen right now saying, "No, we fucking know. We know the Earth's a globe, and this is the sun, so we know it can't be pointing fucking north. This is the way the magnetic lines and fucking, But like I said, man, I got declination here where I'm at, and my compass points right to Polaris. So, that would be my argument. Not a whole lot to back it up, but just saying, as far as a method goes, like they have their error bars, things like refraction. So we know the Earth's a globe, and the sun's right here, or this thing's right here. We know that the Earth's curve calculates this, so 7/6R is standard. That means that's always. So it's always between 20 and 30% flatter than what it should be, because that's just standard refraction. And then, if you need 4/3R or whatever, whatever you need, so that's how they would predict the refraction, and it ain't vice versa. You don't tell them the temperature and all that, and then they tell you what you're going to see. That ain't how it works. But they know, since they know that the Earth is a ball, they know that how much the light's refracting, because they know the math of the curve. So that's how it works. So same thing with, in my opinion, same thing with the declination. So they know the Earth's a ball and the sun's doing this path, and so we know that the declination is off. We know that the compass is wrong, and but in reality, it's all based on they know. And same thing with radius. So we know the Earth's a globe. So we know the sun's 93 million miles away. We know the stars are infinite distance away. So we know it's parallel, and so we can claim, we can equalize these measurements coming from the center of the Earth, because we know all this. We know the radius. It's all fucking based on the fact that they know with 100% certainty. So, but they don't know. I don't think, I'm not going to claim I know exactly what the Earth is. I'm not 100% sure it's flat. I like to argue that it's flat and all that, but as far as knowing anything for sure, no. Reality don't work like that. But on the other hand, they got a excellent model as far as explaining explanation's sake. As far as for practical reasons, that's arguable, but even that, they got basically the one and only model. And we're all here talking, man. We need to do something, man. We need to make a fucking map that's a little closer. Like the North Pole to the equator doesn't have to be quite as far. With a straight line, it could be a little bit smaller. And then in the populated areas down beneath that, like Capricorn and shit, don't have to be, 40,000 miles around. It could be closer to about 30,000, and doesn't have to be a 60,000 mile ring of ice. It could be more like freaking 50,000, and that puts the distances a lot more manageable. But it's going to take us putting our heads together, and it's just, hey, if anybody can talk right now, is the guy that Eggshells is talking about mapping the oceans? Is he is he a globe earther or a flat earther?
Yeah, I'm pretty sure he's a globe earther.
Well, why is he trying to map the oceans? I mean, if he's a globe earther, I don't get it.
Oh, I don't know. I have no idea. Might have just been a hobby. Might have been a sailor or something like that.
That's fair enough. But I would just think that if it's already mapped, why map it if it's already mapped? I would say that if you want to make your own map that's accurate, if you already have an accurate one, I don't get it. But maybe he'll explain that.
I think Eggshells is wanting to host because he's live streaming and he wants to host. Do that temporary host where he.
Yeah. Oh, look, man, is he trying to make a presentation? Because I'm sure we'll gladly all go on mute. I'd love to hear it.
Yeah. I think he wants to get Geo's permission prior to,
Or even his attention, maybe, if he's going to go through all that. Geo needs to make a flag button or like a raise your hand button on there. So, when I stop talking, if nobody picks up, filling the dead air, then I know there's still a few people listening and shit. Because I listen sometimes, I can't even talk. I can't even respond sometimes when I really want to. But so he could join and just be dead air, not even knowing somebody's waiting. Maybe somebody messaged him or something like that. But I'm anxious. Maybe the guy can join and kind of give us the outline of what he's even talking about. Maybe the methods. We have a good idea of what he's talking about when he starts the presentation. Or I'll just wait. What's his name again?
IB Hunter.
Oh yeah. Well, before he joined, I want to say one other thing. I didn't get this in earlier, but man, I swear, man. I mean, not trying to brag, maybe even brag a little bit, but I was one of the first people to look in or talk about the Google satellite project, man, a long time ago when I first heard about this shit. But I found the article. It was after, but it was a 2012 article with Google Project Loon. Before hardly anybody heard about it. I ain't saying I was the first, but I'm one of them because I never heard shit about it at the time or much at all about the. But anyway, I was looking into NASA's balloons and all that, like the first satellite, that big giant one and everything. So I was just really into it. So I just dug far and wide and found the Project Loon, and they were describing these these balloons that they had in this one center, like previous to 2012, that was putting out these balloons and staying up for a few months at a time and everything, describing their methods of hooking them and all this stuff. And then they said, but now in 2012, we can do, a dozen a day and put these balloons up, like I said, that stay up for a few months at a time. And now there's not only can they do 12 a day, there's or they said a dozen. They said now not only can we do a dozen a day, there are dozens of these facilities across. I don't remember if they said world or nation or something, but dozens with an S on. So I didn't get an exact number, but so that the one starter facility was putting up. We're talking 12 a day, and now there are dozens. So that's at least two, but probably three. So we'll be conservative and just say there's three, just going off definition. So that'd be, three doing 12 a day. That's kind of conservative if you ask me, but that's 36 balloons a day that are staying up for 3 months, each one. So in 1 year, we can get rid of, if they're staying up for 3 months, we can get rid of 25% of them just from having to come back down. But let's see, or we could actually get rid of, let's just get rid of half of them, man. Don't feel like doing the math on that. But since they're only up for 3 months, we'll just cut that whole figure in half. And then, so we'll say 18 a day. That'd be, 6,000. If we just got rid of half of them because they only stay up for 3 months, and that'd be 6,570 balloons they'd have up in 1 year, pretty much all the time. And that's back in 2012. So knowing about the LTE satellite balloon network that they had for cell phone service, if I remember right, they had 12 of them in blanketed South America, with I guess the populated areas of South America, with 12 of them fucking satelloons. And it's hard to find this information, like very hard. I've already seen it, read it, videoed it. Made a video about it and all that. And right now, if I tried to find it, I'd be lucky to find it. Like, why? Why would this information? It's great information, man. You're talking about affordable fucking satellites that any one of us could put up within reason. Any one of us with a little extra money. It's within reach anyway. Okay, it's we're not talking about millions of dollars or even hundreds of thousands. We're talking, probably 20 grand. Put up some transponders. Balloons probably 10 grand. Oh shit, they got a spider. Probably 10 grand for balloon and the helium or whatever, and another 10 grand for badass transponders, whatever.
All right, Writing's gonna come over to Livestream 2 and do that stream with IB Hunter. If y'all want to come down and check it out.
Where?
Livestream 2.
Sure.
All right, so yeah, should I start like a new? Let me see where we're at. I think I actually had reset this stream somewhat recently, but should we just do a new one so it's like its own actual YouTube video?